Welcome to Mr. O'Brien's Opus Science tutoring video. In this lesson I will be covering the main points from Chemistry Chapter 1, Matter and Change. Some of the goals that we will have for this chapter will be to understand the scientific method, how we can use that to help us classify matter, how we name different elements and the international symbols used to identify them, also how we can distinguish different kinds of changes, physical changes, from chemical changes. Let's begin with this question. What is chemistry? When you think of chemistry, do you perhaps think of a scientist in a laboratory with different vials and beakers and test tubes filled with strange liquids and other substances? Well, while chemistry can certainly be that, chemistry is also a lot of different things. Essentially, chemistry is the study of the nature of matter and its properties. In this study, it really has profound philosophical implications, in fact, because ultimately we're trying to understand the basic nature of reality. We'll also be studying the composition of substances and the changes that they can and do undergo. We'll be using the scientific method to help us to understand this. Human beings have done this for centuries, but particularly in the last few hundred years have we refined this as a way of gaining knowledge. We see things, we make observations, we ask questions. Why is it that way? Then we come up with educated guesses. We call that a hypothesis. And then the science really gets going when we try and design some sort of experiment to disprove or at least try and support our hypothesis. After we conduct that experiment, we'll analyze the results, make conclusions, and repeat the process and so on in gaining our understanding. But the fact of the matter is, there's not just one scientific method. There's many ways to do science using these various tools, and they don't always happen in exactly that order. Science is really an approach to the solution of scientific problems. It's a way of seeking to understand the natural world. It is, in fact, a way of thinking. Experimentation, I mentioned earlier, is a very important part of the scientific process. Experiments are ways to test a hypothesis. Experiments must also be repeatable. This is very important. Why is that? Well, when a scientist or a group of scientists conduct an experiment and they come up with certain results, other scientists and researchers should be able to conduct the same experiment in the same way and get the same results. When that happens, then it tends to confirm those results. If we don't, then we have some problem in the methodology of perhaps the experiment design or something. That's something we'll look at further along as we continue our studies. Some key terms you want to make sure you understand are these: hypothesis, theory, and law. In general conversation, people use these somewhat loosely. In science in general and in chemistry in particular, we want to make sure we're very, very specific in how we use these terms. And when you study the chapter, make sure you really read carefully, that you understand what each term means, how it's used, and how they're related, but the subtle distinctions between them. I'll give you a little brief explanation of each to kind of give you a quick start. A hypothesis is a proposed explanation for something. It's just that. And then we'll submit it to different experiments to see if it stands up or not. When an idea has been thoroughly tested, that explanation has been thoroughly tested through experimentation, then we can say that now we have a theory, a good working explanation of things. Now, that doesn't mean that that theory can't change or later on be proved wrong, as many theories have. But that's when further evidence and more data comes to light. And then we have new explanations for things. Now, a little bit different is the idea of a law. A natural law or a scientific law, for instance, the law of gravity, is not meant to explain anything, but rather to describe a natural phenomenon. For instance, here on Earth, a falling body will accelerate at 9.8 meters per second per second. That just says what happens, not why. So get familiar with those terms: hypothesis and theory and law. Some other ways we classify matter is looking at its properties and the states in which matter can exist. Let's back up a second and let's just kind of have a broad definition of matter. Matter is anything that takes up space and has mass. That seems very straightforward and simple initially, but It's very deep when you think about it. Anything that takes up space and has mass. As we continue through our discussion of chemistry, we'll see that that's actually not only a very useful definition, but it's one that is important in many different ways. It's very general, though, and so to identify different kinds of matter, we need to be able to distinguish them. And to distinguish them one from another, there are certain things we can measure, and those are the properties such as color, density, hardness, things like that. Matter can also exist in different states. Matter can exist as a gas, or as a liquid, or as a solid. You might even be able to think of a very common compound that can exist in all three of those states. What comes to mind? No doubt you've seen before the periodic table of the elements. This is a tool that we will be using extensively throughout our study this year. We'll come back to it not only to see how scientists have collaboratively contributed to building this chart as a way of understanding elements and their different properties, and we'll also use it as a way to enable and help your understanding of different elements and their properties and their behavior. Elements, by the way, just to make sure we're clear on that term, are the simplest form of matter. Elements can't be separated into simpler substances. A particular element of one kind is what it is, no matter how much you try and break it down. For instance, if you had a bar of gold, or a chunk of iron, or of carbon, if you took any of those elements, if you tried to break it down into smaller and smaller components, no matter how small you could go, to the single smallest particle of that element, it still would be just that. It's not made up of anything else. And when we have large collections of that element by itself, it is just that. Looking at the periodic table again, you'll notice in each box that there is one or there are two letters. Those letters come from the beginning of the name of each element. Now often, like in oxygen, in the case of oxygen, the O is the first letter of the English word oxygen. But sometimes we have elements where the letters don't match up to the English word. For instance, iron. Its symbol is the first two letters, F and E. Well, why is that? People, as I mentioned earlier, have been studying about the different elements for a long time. And so some of these terms actually come from more ancient languages. For instance, the Fe that is the symbol for iron comes to us from the Latin word ferrum. And you'll find that many of the different terms and the names of the different elements in the periodic table come from different languages, primarily Latin. Elements can combine to form compounds. For instance, the gases hydrogen and oxygen can combine to form the very common substance, water. How that happens and its implications, which are huge, are going to be questions that we will return to several times, many times in fact, throughout the course of our study this year. Different substances, both elements and compounds, can combine in different ways to change and form new substances, often with very different properties of the original elements or compounds. A way we represent this looks like this here. We have on this page iron and sulfur, the elements combining through a heat reaction to form a compound iron sulfide. The important thing you need to get from this right now is just the basic look of how we represent a chemical reaction. In this case, a relatively simple one. Now you might notice that this kind of resembles an algebraic equation, only instead of an equal sign we have an arrow. And in fact, it is important that both sides balance. And that will be a subject we'll come back to repeatedly. And that's a very important concept in chemistry. You'll notice that whatever is on the left, whether it is a combination of elements or substances, they are referred to collectively as the reactants. Whatever we end up with, the result on the right side is called the product or products. So those are very important terms. The reactants are on the left, the products are on the right. Some other things we need to be able to distinguish in our study of chemistry are different kinds of changes, a physical change as opposed to a chemical change. A physical change is when a substance alters its physical manifestation but it still is what it is. For instance, when water freezes and becomes ice, it goes from a liquid to a solid, but it is still water. Correspondingly, when that ice melts and becomes liquid again, it is still water. So it hasn't changed its essential chemical composition. A chemical change, on the other hand, excuse me, chemical change is when that essential composition does change. And that's something, while we might see some sort of large-scale, macroscopic change with our eyes, what's really going on that's important happens on a much smaller, a microscopic or molecular level. And that's going to be an important concept for us to look at as we move forward. It involves the making or breaking of bonds between atoms. Now, don't worry if you don't understand it at this point. Just have it out there and you're being introduced to this concept. So, there are our goals for this chapter. First and foremost, knowing that it's not the, but a scientific methodology, a way of thinking about things and understanding nature. One of the things we do is try to classify matter, and we do that by naming the different elements. We have internationally used symbols for each element. That's organized in a table, a chart, the periodic table of the elements. We also need to be able to distinguish different kinds of changes, physical from the chemical. And those are the four main goals. Hopefully this video has helped you, given you an overview of what you need to learn and understand from this chapter. If you have any further questions, go ahead and visit my Opus Science Tutoring webpage. And if you scroll down on that page a little bit, you'll see a blog for Chapter 1 of Chemistry, where you can both post questions and share with your classmates any answers that you have or any insights. We definitely want this to be a peer-assisted, a peer-tutoring collaborative process. So I hope that helps, and that's all for now, and I will see you in the next lesson. This lesson was prepared in alignment with the next generation science standards.